Welcome to Chapter 5 of Class 8 Science, Exploring Forces. In this exciting chapter, we'll discover the invisible pushes and pulls that shape our world. We begin with a story about Sonali and Ragni's cycling adventure, where they experience different forces firsthand, from pedaling uphill to feeling the wind push against them. Forces are everywhere in our daily lives, and understanding them helps us explain why objects move, stop, change direction, or change shape. We'll explore different types of forces, learn how to measure them, and discover their practical applications. Get ready for a journey into the fascinating world of physics. Let's begin by understanding what a force actually is. In science, a force is defined as a push or pull applied to an object. It results from interaction between objects and can change an object's motion or shape. Forces are measured in newtons, named after the famous scientist Isaac Newton, and are represented by arrows that show both direction and magnitude. In Activity 5.1, we'll explore forces hands-on by trying to move a large cardboard box in different ways. You might push it, pull it, lift it, or carry it, but in all cases, you're applying a force. Forces are present in countless everyday situations. Opening a drawer involves a pull, kicking a football involves a push, and even chewing food involves muscular forces inside your body. Now let's explore the various effects that forces can have on objects. When a force is applied, it can make a stationary object start moving, change the speed of a moving object, change the direction of a moving object, change the shape of an object, or stop a moving object. Sometimes, a force can cause several of these effects simultaneously. In Activity 5.2, we'll analyze different situations where force is applied. For example, when your friend holds your moving bicycle from behind to stop it, the force decreases the bicycle's speed until it stops. When you hit a moving ball with a bat, you change its direction. When you press an inflated balloon, you change its shape. Understanding these effects helps us predict how objects will behave when forces act upon them. An important concept to understand is that forces always involve interaction between objects. There's no such thing as a force acting in isolation. It always requires at least two objects interacting with each other. When you push a table, your hand and the table interact. When a magnet attracts iron, they interact. When Earth pulls an object downward, they interact. Forces come in pairs. For every action, there's an equal and opposite reaction. This is Newton's third law of motion. Try pushing against a wall with your hand, you'll feel the wall pushing back against your hand. The moment you stop pushing, this force disappears. This demonstrates that whenever two objects interact, each object experiences a force from the other. As soon as the interaction ceases, the force disappears. Now let's classify forces into different types. The main classification is between contact forces and non-contact forces. Contact forces require physical contact between objects. Examples include muscular force, the force from our muscles, frictional force, which opposes motion, and normal force, the support force from surfaces. Non-contact forces act at a distance without physical contact. Examples include magnetic force between magnets, electrostatic force between charged objects, and gravitational force, the attraction between all objects with mass. Muscular force is particularly interesting. It's what enables animals, including humans, to move, lift, push, and perform various tasks. Throughout history, before machines were invented, people relied heavily on muscular force from both humans and animals for farming, transportation, and construction. Let's take a closer look at friction, one of the most important contact forces in our daily lives. Friction is a force that opposes motion between surfaces in contact. It always acts parallel to the surfaces and in the direction opposite to motion. Friction arises from microscopic irregularities on surfaces that interlock with each other. In Activity 5.3, we'll investigate friction by pushing an object across a surface and observing how it eventually stops due to friction. In Activity 5.4, we'll explore how friction depends on the nature of surfaces by testing the same object on different surfaces like glass, cloth, wood, and sand. We'll discover that rough surfaces create more friction than smooth surfaces. Friction isn't limited to solid surfaces. It also acts on objects moving through liquids and gases, which is why vehicles are designed with streamlined shapes to reduce fluid friction. Now let's explore non-contact forces that act at a distance without physical contact. Magnetic force acts between magnets or magnetic materials and can be either attractive or repulsive. It's strongest at the poles and can act through non-magnetic materials. In Activity 5.5, we'll explore magnetic force by bringing a magnet near iron objects without touching them and observing the attraction. Electrostatic force acts between charged objects. You might have experienced this when your hair stands up after rubbing a balloon on it. Gravitational force is the attraction between any two objects with mass. It's the weakest of the fundamental forces but acts over large distances. Earth's gravity pulls objects toward its center, keeping us grounded and planets in orbit. In Activity 5.6, we'll simply drop an object and observe gravity in action. The object falls toward Earth due to gravitational attraction. Now let's explore the important concept of pressure. Pressure is defined as force applied per unit area. The formula is pressure equals force divided by area. The SI unit of pressure is the Pascal, where 1 Pascal equals 1 Newton per square meter. The same force can create very different pressures depending on the area over which it's distributed. In Activity 5.7, we'll explore this by placing a brick on sand in different positions. First on its largest face, then on smaller faces. We'll observe that the same brick creates deeper impressions when placed on smaller faces because the force is concentrated over a smaller area, creating higher pressure. This principle has many practical applications. Sharp knives have small cutting edges to create high pressure for cutting, while school bags have wide straps to distribute weight over a larger area, creating lower pressure on our shoulders. Tractors have wide tires to create low pressure on soil, preventing them from sinking. Understanding pressure helps us design better tools, structures, and equipment for various purposes. As we conclude this chapter, let's review the key concepts and their real-world applications. We've learned that a force is a push or pull resulting from interaction between objects. Forces can change an object's motion or shape. We've explored different types of forces including contact forces like muscular force and friction, and non-contact forces like magnetic, electrostatic, and gravitational forces. We've learned about pressure as force per unit area and how it applies to everyday situations. An important distinction to remember is between mass, the amount of matter in an object, and weight, the force of gravity on an object. Your mass remains the same everywhere, but your weight would be different on different planets due to varying gravitational forces. Understanding forces helps us explain natural phenomena and design technology that makes our lives easier and more efficient.